absolute value of x, and then I'm going to move this, but we're going to do it on Desmos so you guys can see what it looks like. So haven't used this before. I'm just going to pull my lovely internet up, and you guys might have this bookmarked if you've used it before, but it's just desmos.com. And I'll just show you from scratch. I have it bookmarked. Okay, this has a bunch of different, let me scooch it up so you can see. This has a bunch of different things that it can do here. Like, we're going to use the graphing calculator today, but you're just going to click on this button in a second. But this scientific calculator, if you don't have one, for function, matrices, I haven't used the geometry or the 3D, but you're welcome to check it out if you want to. This is all totally free. You are not going to log in. You are not going to sign up. Don't do that. It's not something you have to log into. Just click right on this, like it says open graphing calculator, and it'll give you the graph. On the left side here is where you can type the equation. The one thing I would tell you, a lot of the stuff in this new textbook is writing stuff in function notation, but Desmos isn't super comfortable with function notation. So I'm just going to write y equals, and does anybody, I'm going to write just y equals the absolute value of x. Anybody know how to code absolute value? ABS? You can do the little settings if you want to get an absolute value symbol, but at a calculator computer you can plug that in, just type ABS for absolute value, and then just in the parentheses I'm going to put the x. And you'll see that's the first graph I have right here. This is already on the paper for you just so you can look at it. What I'm going to do is have us compare what happens if I plug a number into the absolute value with the x either added or subtracted. Okay, now for the first one. This says I have x minus h in the absolute value. This is a little weird. So if I plug in 3, I'm going to do y equals its absolute value of x minus h, and I'm saying I want us to have h be 3. So it would just look like this. Y equals absolute value of x minus 3. That's what the equation would look like. And I'm just going to come over to my Desmos. If you just click on the second line, I'm going to type y equals ABS for absolute value, and then I'm going to do x minus 3. Okay. Tell me, what did that do to the original graph? So the original graph I just had plain absolute value of x, called the parent function, most basic version. If I put that minus 3 in the absolute value, what did it do to the graph?
It shifted the x-axis.
Shifted. Okay, which way?
On the x-axis.
On the x-axis. 3 to the right, yeah? Okay, so I'm just going to jot this down. So this went, it just took everything right 3 spots. Okay, if you want to put it on the little graph here on the notes, I almost went the wrong way, forgive. So the vertex, instead of being on 0, 0, is on 3, 0. And if you want specific points, you could grab them off that graph, but if you want, you could just go up 1, over 1 on either side of the middle of that, and that will be matching points with the graph. Just starts at, or the middle of it is at 3, 0. Just go up 1, over 1 on either side of that, and that'll create that V shape. Now, the other one, I'm going to have us plug in -2. All right, now this is just a slight bit weird. The way this is set up, it is x minus what I ask you to plug in for h. So it would be x minus -2. What would you tell me minus a -2 is the same as? Plus 2. Okay, so when I actually type this in, I'm just going to write it like that. Let me get rid of the one I'm just going to type right on it. I'm going to do x plus 2. Okay, now, which way did that make the graph go?
2 to the left.
2 to the left. Okay, so this goes left 2. So if I were to put that on the graph up here, instead of starting at 0, 0, that vertex is at -2, 0. And again, if you want to just go up 1, over 1, those would be specific points. Or you could look at the graph on the Desmos there. And that goes left 2. Now you're probably like, okay, Miss Brody, why are we, I'm going to get rid of my Desmos now. Why am I doing this? This, I think, is the hardest translation to remember, because most of the time if people look at an equation like this is x minus 3, I see a -3 and I think that should be going to the left. Or I look at this one and I see a +2 and I think that should be going to the right. It actually goes the opposite direction, if you guys can see that. So the reason I wanted to show you this, the reason this goes the other way than what you think, if I plugged in 3 to this equation right here, what would be in my absolute value? If I plugged in 3 for x, what would that make the inside of that? 0, right? Okay, so that's why it's weird. If I plug in positive 3, that makes this 0. That's where it switches from one side of the b to the other. That's why it's the opposite of what it looks like, because it's what sets this equal to 0. Like if I plugged in negative 2 here, makes that 0, that's where it switches from one side to the other. So just to write this down so you guys have it. If you have, I'm going to say inside, this works for every type of graph, not just absolute value. Like it would work for a parabola, it would work for a square root, it would work for a sine function if we did that. I'm going to say inside the operation. And what I mean by operation, like in this case, it would be the absolute value. Inside the operation with x moves either left or right. Oh my goodness. My computer is having a seizure. I don't know what's going on. Sorry. Okay, sorry about that, guys. I don't know what just happened. All right, anyway, it moves. It's going to go left or right the opposite way that you think. Sorry about that. That was super weird. Okay, I have no idea what just happened. All right, so it's going to move left or right the opposite way you think. Let me make this so I can read it. All right, left or right, opposite way you think. And this is super important. This works for any type of, I said operation. So like absolute value, square root, if I square something, if I take the cube root of something, this works for every type of graph, not just the absolute value. If you're shifting left or right in the equation, it goes the opposite way that you think. So let me just, I'm going to go to the side and give you a couple little examples with some numbers. So like if I had, I don't know, like if I have x plus 5, this would go left 5. If I had in parentheses x minus 7, then that would go right 7. And that's the hardest one to remember. So if it's inside the parentheses with the x, it's going to go the opposite way that it looks like. So like if I see a plus 5, it actually is negative 5 going to the left. And if I see a minus 7, it's actually a positive 7 that I would plug in there to make that 0, so it goes to the right 7. This is the hardest one to remember, so that's why I wanted to show that to you guys on Desmos. Is anybody having a question? Okay, now, translation in general. We just did a translation on those lovely pictures we did. It can either go left or right. I'm kind of adding this in. Or it could go up or down when we translate. Like literally all the points would go like left 2, or maybe they go right 5. They could go up 6, they could go down 10, whatever. So a translation is moving all the points, and this will say in the same direction, bless you, same direction and same distance. So like every single point goes over 2, or every single point goes up 10 or whatever. So they go the same direction, does not change the shape of the graph. What I'm going to have you guys do is I'm going to show you a graph, and we're going to shift it based on the directions here. But before we do that, I'm just going to have you do the range. I got the domain for the graph. I have this guy right here. I'll just write it so it's not in function notation. It's just like y equals x squared, but it only goes for the domain between -2 and 2. Tell me, for this lovely picture right here, what are your possible y values for your range? Like no infinity symbols here because I got no arrows, but what y values do I go between there? What do you think? 0 and 4. All right. So lowest y value right there, 0. Biggest y value is 4. Okay, now here's what we're going to do. We're going to translate this graph. In the directions, right like here, it says we're just going to take everybody 3 units down. You don't have to use the equation to do this. I'm literally just going to sketch this on the graph. Okay, easiest thing I can tell you to do if you have a graph, like grab a point, like I have a nice point here. I'm just going to scooch it down, 1, 2, 3. There's my new point. Just grab a couple points on the graph, and maybe the vertex. I don't have like a dot there, but just go down like 1, 2, 3. And then just do your best to make it a U shape. It doesn't have to be perfect. Now, my new graph, let me write your equation over here. This would be x squared. There's no parentheses, so it's not inside the operation where I'm squaring all the points there. It's outside the operation. It'll just be like x squared minus 3. Now, that scooches the entire graph down 3 units. Is my domain the same or different? Same. It's between the same two values. It does not change the domain when you go up or down. All right, so this is still -2 to 2. Just like it was in the original. It's still between those two values. Is my range different? The range is different because we scooched everything down 3 spots. Okay, so if I just look at that translated graph, first y value I touch now is -3. What's the last y value I touch? 1. So this changes the range if you scooch the graph up or down. Now, I'm not trying to confuse you in any way. This is actually a little bit more straightforward when you see the equations if you have what we call a vertical translation. A vertical translation, in general, you have your function and then you have something added or subtracted to the side. So like over here when I did this, my function was the x squared and I had the -3 next to that. There's no parentheses in that equation that I wrote there. This is going to be a vertical translation. That moves the graph up or down. Okay, I'm going to write this. So this is outside the parentheses. Right, outside, right, I have f of x right in that notation if you guys see that. Or if you see, I don't have any parentheses at all where I wrote y equals x squared minus 3. This is outside the parentheses. And what this is going to do, we're going to do up or down. And then I'm going to say the way you think. So like, if I look and I see a -3, I think we're going down 3, and that's how it works. If we had a +5, like an x squared plus 5, that would go up 5. So it's outside. It's not a trick. If you see something subtracted, you're going to go down. If you see something added, you're going to go up. That's more straightforward. Now, example 2, this is a horizontal translation. So this is going to be kind of like that one that we did at the top, where the actual equation is going to look a little bit different than what you think it might in terms of the positive and negative. Now, I have the exact same graph, so I'm just going to go ahead, let me just write the range there. So this is exactly the same graph that we had above. This y equals x squared. It's just going between -2 and 2. This guy's direction, horizontal, is going to be left or right. This one's asking us to go 3 to the right. So I'm just going to grab a point and literally just scooch it just right across three spots. Just count 1, 2, 3. And I'm going to move the origin, so instead of being 0, 0, it's going to be 3, 0. Okay, did my domain change?
Yes.
Yes, okay. So originally, like the first x value I touched here was -2, but we scooched everything over 3 spots. So now the first x value I touch is what? 1. What is the last x value I'm going to touch? 5. Okay, perfect. Now, is your range the same?
Yes.
Yes, this does not change. This is between 0 and 4. It's scooched over, but the y values are between 0 and 4, so the range is the same as the original. Okay, now, this is the equation for this graph. This would be y equals, now, in parentheses, I'm going to write x minus 3 squared. That's the equation of what we just wrote. It's just on that domain from 1 to 5. So inside the parentheses goes the opposite way that you think. Like to me, I go, okay, -3. It's actually +3 because it's going 3 to the right. That's a horizontal translation. So I'm going to put that on the bottom line here. This is horizontal. This is the tricky one. This goes left or right, but the opposite way that you think. So like this is inside the parentheses. Inside the parentheses. And I'm going to write down, this goes the opposite way that you think. So if it looks like a minus, it's actually positive. If it looks like a plus, it's actually a negative and going to the left. Is anybody having a question? Okay, I know this notation is super tricky. So I'm going to do just like a little tiny summary at the top just to give you an example with some numbers, okay? So let's say I don't have an equation, I don't have a graph, right? Let me just write something for you. So let's say I have, in parentheses, I have f of x minus 6. All right? Inside the parentheses. This would go right 6 for that notation. So if it's inside the parentheses, like to me I see that as a negative 6, but it's really a positive 6 in terms of the transformation that it's going to make. So that's what it would be. If I had something like this, let's say I had x plus 5, I don't know, that would go left 5, just so you guys can see the notation. So if it's inside parentheses, it's going to go left or right, the opposite way you think. All right, for the vertical, let's say I had just f of x on its own, and then outside, if I have, I don't know, let's say I had minus 6. That outside goes up or down the way you think. So this would go down 6 if you got this notation. If you have f of x by itself, and then outside, let's say we had plus 5, then this would actually go up 5. So inside with the x is the tricky one because it goes the opposite way that you think. Outside the parentheses, it's just up or down, just copy that number. So if it says negative 6, you're going down 6. If it says positive 5, you're going up 5. So I'm going to have some questions like this in example 3 here, where I give you the graph, and it's kind of telling you, based on that function notation, how you want to transform that. So if I say we're going to graph, and we're going to take this graph, and I'm going to write it as f of x plus 2. Can you tell me, like, what would you do? Like left, right, up, down? If you looked at that equation. How do you think it would go? Like, how would you shift it? What do you think?
Left 2.
Yes. Okay, now, if any of the questions say describe, this is all I mean, is for you to write left 2. Okay? If you want to write left 2 units, please. I'm just going to write left 2 because I'm lazy. So literally, just grab any point you can, just scooch it over 2 spots, and I'm going to play connect the dots. That's all you have to do. It's just really tricky sometimes when you first start looking at this notation to know which way am I supposed to go. So that's what you're trying to figure out here. All right. If I take this little different graph, this is just a little line segment. If I have f of x plus 2, tell me how you would move that line segment. Up 2. If it's outside, you're going up or down, and if it's like a positive, you're going up. If it's negative, you're going down. To actually do that, I'm just literally going to take these 2 endpoints, just scooch them up 2 spots. Play connect the dots. Just scooch it up 2 spots. Let me add one little problem in because there's one like this on the homework, so I'm going to use a little space. Let's say I gave you f of x, I don't know, I'm going to make something up, minus 5, minus 3, all in the same problem. I'm just making this up. Can you tell me how this would move a graph? If I had x minus 5 in parentheses and then outside minus 3, what do you think?
Right 5 and down.
Perfect. So this would be like a 2 for 1. This would go right 5 and also down 3. So you could have 2 in the same spot. Like we would just take every point. You could go right 5 and then down 3, or you could go down 3 and then right 5. It would put you in the same spot. It doesn't matter the order that you do them in, but you could have like a 2 for 1. There's one question like that on the homework. Is anybody having a question? Okay. The other thing we're going to talk about real quick is a reflection. So we did translations. We're going to do reflections. This is just 2 possible things that can happen. So reflection doesn't change the shape or the size, it's just going to flip the graph over. So transformation of a function flips each point over what we call the line of reflection. Those are those 2 little blanks there. Okay, now if you all did this in geometry, if you got to that transformation unit and you did some reflections, they maybe had you go over like y equals 3 or something like that. We're just going to reflect over the x and y axis, nothing weird. So there's just 2 rules, one's for the x-axis, one's for the y-axis. All right, so if you reflect over the lovely x-axis, so that'd be your horizontal axis, we're just going to take some and flip it over the x-axis. If you have a point xy, that point, if you reflect it, would change to, the x would stay the same, and the y would become opposite. So I would write that as x comma negative y. Now let me just give you a tiny example with a number. So like let's say my point was 4, 7. If I reflected that over the x-axis, it would be the point for negative 7. It would just flip the y-coordinate. That's how that would work. And then let me give you the notation for this too. So the notation for this in the function, you would take and you would multiply the entire equation. If you had the equation, take the entire thing, multiply it by negative 1. That would flip it over the x-axis. If you flip over the y-axis, that's this other one, that takes and makes the x-coordinate the opposite, so negative x, and it keeps the y-coordinate the same. I'm going to use that same point as an example. So if I started with the point 4, 7 and I wanted to flip it over the y-axis, it would become negative 4, 7. So the x-coordinate flips, the y-coordinate stays the same. The notation for this is just a teeny tiny bit different. You would have f, and then in the parentheses, you would make the x, just the x negative. I'm going to show you how to do that algebraically in this last example. Is anybody having, guys? This is tricky. Okay, is anybody having a question? Okay, so I have a little line segment graph here. Domain goes from negative 4 to 4. Tell me what the range would be for this little picture that I have here. What between what two y values? Go from the bottom to the top. What's your lowest y value? What do we think? What's my lowest y value in that picture? Negative 1. Okay. What's my biggest y value? Perfect. Okay. Now, we're going to reflect this over the x-axis. All right, this is not a big to-do. Just count boxes. All right, so see how far you are away from the y-axis. So like here's the point. This is 4, 3. I am 3 spots away from the x-axis, so I'm just going to go 3 spots away on the other side. That's it. This guy is 1 spot away from the y-axis, go 1 spot away on the other side, and we're going to play connect the dots. That's it. Not a big deal. Okay. Did my domain change if I flipped it over the x-axis? Like left to right? No. If you guys see, this is still between the same two. So the domain stays the same here. So this is negative 4 to 4. The range changes though, because now this, sorry, I got a little carried away and drew outside that point. The range changes because this goes down a little bit further. So my lowest y value now is negative 3. And my highest y value is going to be this point right here that has a y value of 1. So it does change the range. Now, I'm going to show you this algebraically. There's a question like this on the homework. So the original problem gives you the equation, right? This is just like a mx plus b. So the equation says f of x, or just if you want to do y equals, that's fine too. This would be 1/2 x plus 1. So starts at 1, goes up 1 over 2, right? If you want to show this is reflected over the x-axis, what you do is you take that entire thing and you multiply it by negative 1. So all I'm going to do is I'm just going to put a little negative sign, and my entire function, it was 1/2 x plus 1. 2 steps, I'm just going to distribute that negative sign and rewrite this. So it become negative 1/2 x minus 1. And if you guys look at the graph, right? Look at the y-intercept, right? Negative 1, and I'm going down 1 over 2, down 1 over 2. So it matches that. So you can check that really easily, right? Goes through negative 1, slope, down 1 over 2, down 1 over 2. It changes the slope and it changes the y-intercept to be their opposites. That's over the x-axis. Okay, over the y-axis. So I got the exact same little line segment. So I'm going to go ahead and copy that range that we wrote down. Negative 1 to 3. Now, if we go over the y-axis, just count the distance you are away from the y-axis. That's all you got to do. So this is let's 4, 3. So 4 spots away, go 4 spots away on the other side. That's it. This guy is at negative 4. So it's 4 spots away, go 4 spots away on the other side. This is not my greatest example because the domain's actually going to stay the same here. Usually it would change. I just have the 2 points. They reflect on either side of each other here. So your domain is actually from negative 4 to 4. Starts at negative 4, stops at 4. your range stays the same. They have the lowest y coordinate is on the same point, -1. The highest y coordinate is on the same point, which is 3. Now, this is just a hair different than what we just did. So algebraically for this one, the original, again, f of x, it's just 1/2 x plus 1. You see that on the graph. If you want to do the flipped over the y-axis, you just make x negative. Okay, so I had 1/2 instead of x. I'm just going to replace that with negative x. That's all you do, just put a negative in front of that. And then I'm going to simplify. All that's going to do is make that first term 1/2 times -1x would just turn this into -1/2 x. And then it's still the plus 1 would be the same. If you guys look at the graph though, that's what this is. I'm crossing at 1, go down 1 over 2, down 1 over 2. So it matches that to show that algebraically. There's a question like that on the homework. Is anybody having a question? Okay, I'm going to stop bothering you.